Good morning, students. Today class we are going to discussing about AM transmitters. First of all, what is the AM? Already we are discussing in later units. On previous classes we are discussing about what is the AM. AM means the amplitude modulation. What is the modulation? Already we are discussing these topics in previous classes. Today class we are going to discussing what is the AM transmitter and where you can use and what is the internal blocks is available in AM transmitter we are discussing in this class. Now we can coming to the AM transmitters. We are handy mainly two types of AM transmitters. One is low level AM Dsvfc transmitter and second one is a high level. It's a high level AM Dsvfc transmitter. For you can define this AM is the amplitude modulation. Where you can use this amplitude modulation, we are already discussing that. What is the amplitude modulation? Already know that where you can apply the modulation. But the weak signal is not able to reach the destination point. Have to increase the strength of the signal by using the modulation technique. If the modulation is done based on the amplitude parameter, we can call it is a amplitude modulation. Already know that amplitude modulation means how to take the modulating signal as well as how to take the carrier signal. The modulating signal is low frequency signal. The low frequency signal, it is has the low strength. Further, you can increase the strength of the signal. We are including the carrier signal. The carrier signal is a high frequency signal and it is having the more energy and comparing to the normal signal. For that mixing of these two signals, the carrier signal can carry the information that is a modulating signal. It is reaching the destination point. It is a technique how you can transmit the signal from one place to another place. One or two the signal is having the low frequency or a weak signal. For that we are using amplitude modulation. The amplitude of a modulating signal is supported by the carrier signal. We are simply defining the AM modulation. The amplitude of carrier. Here the modulating signal is not changed. But based on the modulating signal, the carrier signal can be changing. The carrier signal amplitude can be changed in accordance or instantaneous values of a modulating signal is called amplitude modulation. Suppose you can see it is a frequency modulation. We can including the variable parameter in a carrier signal is a frequency parameter. The frequency parameter of a carrier signal is varying with instantaneous values of modulating signal. Is called frequency modulation. Suppose you can define the phase modulation. We are including that the variable parameter is phase. The phase of carrier is varying the instantaneous values of modulating or message signal we are calling phase modulation. Already you know that any signal is having the mainly three parameters. One is amplitude and second one is frequency and third one is phase. In that first technique is amplitude modulation. In amplitude modulation we are having some classification. Those classification is the first one is double sideband. Double sideband full carrier. Double sideband full carrier and the second one is double sideband suppressor carrier. Full carrier and suppressor carrier. And third one is SSB single sideband. The single sideband full carrier as well as the fourth one is SSB suppressor carrier. For these techniques, how you can able to designing the transmitters to deliver the signal at a transmitter point. Here we are having the Dsvfc classification. In that the transmitters we are mainly having two types. One is a low level and second one is high level. Under low level we are calling low level AM Dsvfc transmitter. And the second category we are having the high level. Just here I give the name is high level AM Dsvfc transmitter. First of all, you can see what are the building blocks is there in AM. It's a low level AM Dsvfc transmitter. In that we are mainly having two signals. One is a modulating signal and other one is carrier signal. The modulating signal we are adding to carrier signal. In this process, only the characteristics of carrier can be changing in accordance with the instantaneous values of modulating signal. For generation of this modulated signal, we are assigning to an antenna. The antenna can radiate the signal to either atmosphere, otherwise what are the media have taken. In that media, it can be radiating the signal. For that, first you can see what are the building blocks we are having in that block diagram. The first, the carrier generation, we are using RF. We are using the RF oscillator. This one is the first one, RF oscillator. And second one is buffer amplifier. What is the RF carrier oscillator? Oscillator means without any AC input, it can deliver the AC signal. Is called oscillator. Here we are using RF. RF means is a radio frequency. Radio frequency means we are calling the high frequency signal. The radio frequency we are denoting with 30 to 300 megahertz. We are calling the 30 megahertz to 300 megahertz, the range you are calling the RF range. Here we are using the RF carrier oscillator. Oscillator means without any AC input, it can be delivered the signal. That one is AC signal. For generation of carrier, you have consider the main block is RF carrier oscillator. Only the purpose of this one is it can be generating the radio frequency carrier signal. The carrier signal we are assigning to buffer amplifier. The buffer amplifier is second block in your design. It can be working as impedance matching. Suppose you can directly assign the RF carrier oscillator to carrier driver. It is unable to drive that. Why? Because suppose you can take any plumbing system. In plumbing system, we are not synchronizing of any two pipes. There is a leakage of water. Here also the RF carrier oscillator is not matching with another block with impedance. It is not coincide. There is a chance to losing the signal. For that purpose only we are using the buffer amplifier. The buffer amplifier is acting as the best impedance matching device. For that only we are using the buffer amplifier in between carrier driver and RF carrier generator or oscillator. In these two blocks we are using the buffer amplifier. The main usage of buffer amplifier is it can be giving that impedance matching between RF carrier oscillator and carrier driver. The output of buffer is assigning to the carrier driver. What are the carrier you can assign? The carrier signal can be driven by some device. Suppose we are not able to drive that, we are not giving the proper signal to your device. For that only have to use the carrier driver. The carrier driver, it can be deliver the signal to modulator. What are the modulator had using? That modulator we had to assign to the signal. What are the signal we are obtaining after carrier driver can assign here. This one is a carrier generation. How you can able to take the carrier generation? Mainly you have to consider three blocks. One is a RF carrier oscillator, and second one is what are the impedance matching you have to take in that. For that we are using buffer amplifier. The buffer amplifier can use that the impedance matching between RF carrier oscillator and carrier driver. Once you can design these blocks, the carrier driver can deliver the efficient carrier signal. This one is a total 3 blocks can be generating the carrier signal to the modulator. And the remaining blocks, bottom blocks we are having that. In that, first one is modulating signal source. What are the message we can deliver? That message can assign here. That one you are calling modulating signal or source. Otherwise you can call it as a message. It's an audio message or a video message. Whatever a message we can take in that, it is a modulating signal or base signal. This one is the first block in base signal generation. Next, I have to pass in this band pass filter. The band pass filter can be giving that what are the band we need that. Beyond that band it can be attenuated or completely eliminating that. By using the band pass, we can assign to what are the source we have to take in that. The source can be passing to band pass. The band pass filter only allowing our required quantities. The required quantities can assign to pre-amplifier. The pre-amplifier can doing that. What are the quantities we are having in our source signal? In that source signal, only some quantities having the higher energies. Basically the source is having the lowest signal. But here we can use some push-up for that big signal using a pre-amplifier. But it is not giving the more sufficient energy for delivering from transmitter to receiver. But it is only giving some supporting energy. For that only you have to use the pre-amplifier. Then you can assign to the pre-amplifier output to modulating signal driver. We can access this signal using one driver. That one we are calling for modulating signal. We are calling modulating signal driver. Once you can assign to modulating driver, the output of modulating driver can assign it to modulator. Here 2, 3, totally 4 blocks is under modulating signal. In carrier generation we are mainly using 3 blocks. For message or source signal generation we are using the 4 blocks. In that modulating signal or source and band pass filter and a pre-amplifier and modulating driver, the modulating signal driver. These 4 blocks can be generating the efficient or sophisticated modulating signal to a modulator. Here the modulator has the 2 inputs. One is a message or modulating signal and second one is carrier. These 2 are here can mixing in the place of modulator. The modulator can be given that the combination of carrier and modulating signal. The combination we are passing to band pass filter. Here the band pass filter, it can be eliminating what are the beyond limit of your significant band. As a beyond your significant band, what are the quantities is there, it can be completely eliminated by this band pass filter. Once we can give to the input to a band pass filter, the output can be assigned to linear intermediate power amplifier. Here can increase in this frequency, but it is not sufficient for that. For that only you have to give that the frequency signal you can assign to a power amplifier. The power amplifier can raise the power of the modulated signal. Up to here we are calling modulator. It's a modulation. After modulation we are calling it is a modulated signal. The modulated signal power can be increased by the linear intermediate power amplifier. Then you have to, after applying the increased power to your modulated signal, it can be sending to linear final power amplifier. Why you can use the linear power amplifier means how much of source you can assign at the input side, the same quantity can be increasing at output. For that only you have to assign the same quantities. The output of this one is furtherly assigned to band pass filter. It can be limiting the band of that particular quantity. Then the network can be directly connecting to the through coupling network through an antenna. Here the band pass filter output we are assigning to coupling network. The coupling network we are interfacing to our antenna. After giving the power, you are not directly connecting to the antenna. Enter between the antenna and band pass filter, you are using some coupling devices for impedance matching. For that only you are using the coupling network between band pass filter and antenna. This is the structure of AM transmitter. Once again you can see totally we are having the classification of AM modulator. This is AM transmitters. AM transmitters we are mainly having two types. One is low level AM Dsvfc double sideband full carrier transmitter. And second category is high level AM Dsvfc transmitter. We are mainly having the two types of AM transmitters. One is a low level AM Dsvfc transmitter and second one is high level AM Dsvfc transmitter. We are discussing about the first type is low level. For low level AM Dsvfc transmitter, we are having the any modulator, it must need the two signals. One is a modulating signal and second one is a carrier signal. For generation of carrier signal, we are taking the three blocks. The first block is RF carrier oscillator. The RF carrier oscillator can generating the radio frequency signal. Simply can remember the oscillator means without any AC signal it can be produced the AC output. Here we are using RF carrier oscillator. The device can be generating the RF frequency, that means radio frequency carrier signal. The radio frequency carrier signal of a RF carrier oscillator we are assigning to buffer amplifier. It's a buffer amplifier. The buffer amplifier intention is it is only given the impedance matching between carrier driver and RF carrier oscillator. This one is a carrier driver. The purpose of buffer amplifier main intention is impedance matching between these two devices. The carrier driver output is a complete carrier signal. Now we can able to generating the modulating signal. For that we have to consider four blocks. The first block is modulating signal. Modulating signal or source. Modulating signal or source. This one is we are assigning to band pass filter. Band pass filter. The band pass filter can be filtering what are the needed frequencies and what are the quantities we needed. That only it can be allowing. Beyond that ranges, it can be completely blocking. This one we are assigning to the pre-amplifier. Pre-amplifier. The pre-amplifier can be doing that. The small increasing the strength of the modulating signal. What are the modulating signal? We have transmitting through a band pass filter. That quantity it is increasing by using the pre-amplifier. Is a little bit quantity can be increased. That value we can assign to, suppose you can running or you can lead that mod, we can assign to a modulator. It is having some minimum value of amount in a modulated signal energy. For that only you have using a power pre-amplifier. The pre-amplifier can use the sufficient, that means a cut-in voltages, like cut-in voltages. Here also can give that the cut-in values of the sufficient message signal. Then you can assign to the modulating signal driver. After giving the sufficient energy, it can be able to drive that. For that only you have to use the modulating signal driver. The modulating signal driver output and the carrier signal driver output we are assigned to modulator. This one is a modulator. Is a modulator. The modulator, it can use the output to a band pass filter. It's a band pass filter. Here also you can limit in the band. The band is very important when I have to go to the any communication channel. For that only you have to use the band pass filter. You are limiting the modulated signal. So modulated signal. Furtherly, we can transfer this band pass filter output to the linear intermediate power amplifier. The linear intermediate power amplifier. After getting the signal of band pass filter, after band pass filter we are getting a modulated signal in our band. Once you can obtain this modulated signal, you can assign to the linear intermediate power amplifier. Here you can increase the power of the signal. Once you can increase the power of the signal, then you can assign to the linear band pass filter. You can assign to linear band pass filter. Then we can using this linear band pass filter, if any harmonics or ripples can be there in that band, it can be eliminated. The furtherly output of this one is we are connecting to the antenna. We are not connecting to the directly antenna. For impedance matching, we are using some coupling networks. Coupling network or coupling circuits we are using. Then we have to connect into antenna. This one is an antenna. By connecting to the antenna, it can be radiating the what are the modulated signal you can assign to this antenna. It can be radiating to atmosphere. Antenna means antenna is a metallic device. It can be receiving and transmitting the signals. This is a complete structure of the low level AM Dsvfc transmitter. I can repeat it once again. The low level AM Dsvfc, the carrier generation we are having the 3 blocks. For modulating signal generation, we are having 4 blocks. For generation of sufficient modulating signal and sufficient carrier signal. Once you can generate these 2 signals, we are assigning to modulator. The modulator can mixing this modulating signal and carrier signal. Once you can obtain the modulated signal, it can be passing through band pass filter. The band pass filter is only allowing what is the bands is our required. What is the required bands is available and what are the frequencies we are needed. Those only it can be allowing. Remaining all quantities it can be eliminating. Furtherly, we can increase the power. We are furtherly assigning to this output of band pass filter to the linear intermediate power amplifier. Here the power amplifier work is, it is increasing the power of the modulated signal. Once you can increase the power of the modulated signal, furtherly it can be transmitting to band pass. That is a linear band pass filter. Why you can assign to this band pass filter means if any components is more than our band, it can be eliminated. Suppose we are not eliminating the quantities, there is a chance to getting the noise or our information is collapse. For that purpose only, how to using this linear band pass filter. Once you can getting the output after linear band pass, these are ready to deliver. For delivering purpose, we are taking the antenna. We are not directly connecting to the antenna, we are using some coupling devices for connecting to the antenna. Here the antenna usage is, it can be radiating as well as transmitting the signals to the atmosphere. But here we are using a transmitter section, for that it can be radiating the signal to atmosphere. This is a complete block diagram and a structure of the low level IM Dsvfc modulator. Coming to the second category, the second category is the high level Dsvfc transmitter. What is the difference we can identify the low level as well as high level? For high level, we are using the building blocks is same, but further we are using the more frequency and power. For that, here modulating signal, we are using the blocks is modulating signal and source. This one is the first block. This is the first block for generation of modulating signal, and the second block is band pass filter, and third block is pre-amplifier, and fourth one is the modulating signal driver, and fifth one is modulating signal power amplifier. Here only the difference is we are including the power amplifier before the modulator. Is only the difference. Here you can set that high level. The only the change in a circuit or block diagram is just you are including the power amplifier. This is only the difference. The blocks, what are the blocks already had discussing in a low level, the same blocks can be appear here. The first one is a modulating signal source, the message. The weak signal you can assign to band pass filter. What can do that band pass filter is only allowing what is the band you needed. The required band it can be allowing. The band can be assigned to pre-amplifier. What is the purpose of pre-amplifier? The weak signal it is not having the sufficient strength. You can assign to modulator, it is having some minimum quantities. The minimum energy or power quantities. For that only have to using the pre-amplifier. The pre-amplifier can be increasing the strength of that weak signal. This signal you can assign in high level category to power amplifier. Before power amplifier, first of all you can drive that. You can drive this modulated signal at using modulating signal driver amplifier. It can be accessing what is the signal you can send. The signal can be accessing by the modulating signal, driver, amplifier. The output of this one is we are assigning to the modulating signal power amplifier. Here the change in a low level and high level, only the thing is the power amplifier is included. This is a generation of modulating signal. Coming to the carrier generation. In carrier generation, you are using RF carrier. This one is the first block. And second one is buffer amplifier for impedance matching. And third one is for accessing the carrier signal, you are using the carrier driver. Already these three blocks is we are discussing in low level category. Here also the difference is the carrier power amplifier. The carrier power amplifier. Here the RF carrier oscillator can generate in the radio frequency signal without any AC input. Then the buffer amplifier can give the impedance matching between the carrier driver and RF carrier oscillator. Here the carrier driver can drive whatever the output we can assign to buffer amplifier. The buffer amplifier output can be accessing by the carrier driver. The carrier driver output is delivering to the fourth block, that one is carrier power amplifier. Once you can increase in the power of the carrier signal, it can be assigned to modulator. That one is IM modulator and output is power amplifier. In previous case, we are not including the power amplifier, but here we are including the power amplifier and before the modulating signal and before the carrier signal. Once you can include in the power amplifier, these are handy most strength. The most strength signals we are assigning to IM modulator. The output of IM modulator is the power output. The power amplifier output we are assigning to band pass filter. The band pass filter signal we are directly assigning to antenna. We are directly assigning to antenna, there is a chance to losing the signal. For that only we are including matching network, impedance matching network. The impedance matching network can give that the proper matching between band pass filter and antenna. Once you can connect into the antenna, it can be radiating the signal to atmosphere. This is a complete block diagram of the high level AM Dsvfc transmitter. We can identify here low level and high level, both are on the same block diagrams, but the difference is in high level category we are including the power amplifiers, the position of modulating signal as well as carrier signal. It is only the difference we can identify these two categories. The remaining thing we are discussing in later.